Tonight's project is to make a contrate wheel for a carriage clock. It's an 80-tooth wheel, and let me do the camera here, and I'll show you the details. A contrate wheel's teeth are horizontal to the movement, as opposed to a regular clock wheel, which is vertical. And the reason for that, this sits right in there like that, and I guess that's going to be hard to see. Let me lift it up a little bit. You can see how that sits in there on its own arbor, and the reason for that is those teeth drive the pinion in the escapement, in the platform. It drives those teeth right there, which is very, very small. It's hard to see, but anyway, this sits this way on the movement, so you can see we've got to make a 90-degree angle in order to drive those teeth, and that's the purpose of this guy. Let's see if I can hold that up really close. This has 80 teeth, and the problem with this particular wheel is that some repairer in the past had this in position like this, and the clock was wound, and they moved the platform escapement back, which caused this wheel to spin very, very fast, and then they pushed it back and it hit the end of those teeth and just rounded them all right over. So this wheel's shot. It's no good. So what we're going to do is take, where'd it go? I don't see the, well, here it is. There it is. This is our stock. This is 360 brass, and we're going to turn this right out of that, right on the end. We're going to take this down and face it and so forth, and we'll turn it left on a stub here, on an arbor, so we can handle it and keep it and put it in the horizontal mill and cut those teeth, and then we'll part it off and X out the wheel. The easy part's cutting the teeth, and you'll see that when we get to it. Okay, so now we're going to take this over the lathe, turn this down to this diameter, and take that out of there. We don't need that divot, and then we'll start making the shape for that. Back in a minute. Okay, we've had to make some changes here since you were last here. That 3-jaw that I had here, this 3-jaw, sticks out so far from the end of the nose here that it gave me a lot of vibration. So we went over to the big lathe and took this down to 3/4 so we have a stub, a 3/4 stub there, and we put it in a 3/4 collet, and now we've got it back where it should be, and we need to take this down to 0.805, and that's what we're doing right now. It's still getting vibration. That isn't going to hurt anything, really, because this is not the final cut. If that was the final cut, it'd be a different story. And we're only going to use the face of this anyway. 951. I think I said 0.085. I'll check it again. Get my pliers. don't want to grab these things with your fingers, especially steel. The brass is not so bad, but the steel is, as we say in Maine, wicked sharp. That's still vibrating because I'm taking a really big bite there. If I take a smaller bite, it won't vibrate as much. Let's try changing the speed, that helps. We've got a ways to go. Unfortunately, my DRO on this machine is broken, so I can't speeded up the feed rate there a bit. 899. I don't think it's the bearings in the spindle, because those were changed about 2 years ago, and it really shouldn't be that. Whoops. .883. Okay, we're down. I turned the camera off for a minute. We're down to 8045, close enough. I put a little chamfer on the corner there, just a tiny one. We're only going to use the first little bit of this. There's our wheel right there. So we're only going to use this much. So we don't need all the rest of that. We're just going to face this. Make sure everything's perfect. Which it wasn't. It had a little dip in it. Okay, I've been experimenting a little bit here, and this looks like the best cutter there. This is a boring bar cutter, and I resharpened it. It's very, very small, but I think it's going to work fine. Now we got to get a depth mic and see where we are there. Okay, the actual wheel is .068, so we've got a ways to go yet. We're not there. This cutter seems to be working quite well, actually. Let me see, we got 0, 1, 15. It's about 40, .040. We can also do this. We can do this, .047, and then we can verify it with the depth mic to make sure it's perfect. That's a little faster. Five, 5-0. I'm sort of sneaking up on this. I don't want to take off too much. .060. I'm going to turn this off till I get where I want to be. You don't need to see all of this. Okay, we're about there. In fact, I think we are there. Let's run this in. .07, that's per point. .07, that's perfect. The problem with the original wheel, this wheel, was that the tips of the wheels were worn off or taken off. They allowed this wheel to spin too fast, and then when it hit the pinion on the platform, it just took the top of the teeth off. So I gave myself an extra. God, it's hard to get in the middle. I gave myself an extra 5 thou there for the tip, for the top of the teeth. Okay, now next. Oh, we were going to do this, yeah. 47, 50, 60, 72. That's perfect. 0.072. Now we have to figure this thickness right here, which is 0.030, and we have to take this down to that. And this tool is not, this cutter is not going to do that. We're going to come up with something different. Okay, to get right in here and make that correct, I ground this tool, and I ground a radius on this side right here. I didn't touch the cutting edge, and that radius matches this. Okay, right there. You see that? There. That radius matches that right there. The radius of the original wheel. So we should be able to go in there and make a nice sharp corner. Maybe. We'll see. Ah, yes. Okay, we said this was 0.28, 0.028. Yep, gonna have to move it. 0.039. So we got another 11 to take off. I've got to get these DROs fixed so that I'm doing this guesswork at this point. Wait. 3.035. Hopefully we're there. Yeah, it's still 0.39. I know what's wrong. I set this over just a hair the other day to do something, and it's not totally square with the world. So now we're going to get a better cut. Perfect. Perfect. Okay, that'll be part one. Next thing we're going to put this, we'll part a little of it off back there, and then we'll put it in the horizontal mill and we'll cut some 80 teeth. Okay, thanks for watching. Hope to see you back. Bye.